Hello, on this video we're going to focus in linear programming as continuation of chapter 3. Okay, so I have a definition here. This is according to BJU books or Bob Jones University books. So the definition of linear programming, this is a technique we're going to use to maximize or minimize a particular quantity. And that quantity is represented by the objective function. And under that, as a given set of inequality. That set of inequality is called constraint. So remember those two words, objective and constraint. Also, according to the book, these are the four steps in solving a linear programming problem. So as you can see, for the first step, we have to write an objective of the function for a quantity being maximized or minimized. Step 2, write a system of inequality modeling the constraint on the variable. And then for the step 3, grab the feasible region and find its vertices. Next, last step, substitute the coordinate of each vertex uh, into the objective function to determine the maximum or minimum value. So let's have this example number 1. So as you can see in example number 1, we're going to find what? The maximum value. Okay? So let's say our objective is we're going to find the z. Okay, maximum value of z, so that is 4x plus 5y. And then for the constraint or the inequality function or set of inequality functions, so let's say that is x plus y less than or equal to 20 and 3x plus 4y less than or equal to 72. So if we're going to observe this constraint, they are all positive, so meaning we're going to focus on the first quadrant. So let's draw the first quadrant. Okay, okay, there you go. Like we all know that this is the y-axis and then this is the x-axis. So for us to determine for the y and x-axis under first inequality, let's try the substitution. Because if you still remember, there are two ways in solving um, inequality system. That is substitution or elimination. So in this case, I'm going to use substitution. So I'm going to substitute the x for the 0 so that I could get the value of y. And then same process, I'm going to substitute the y as 0 so that we can get the value of x. So let's try it. So let's try for the value of y. So this is 0, y, 20. So the y-axis or the y-intercept is 20. So let's say 20 is over here. Okay. So same process. We're going to substitute for the value of x, substitute the y as 0. So x plus 0 less than or equal to 20. So x is still the same as 20. So let's say the x is over here, 20. Okay. So let's delete this one. Next, once we find the points for the first inequality, let's move down to the second inequality. Still, same process, substitution, substitute for the value of x as 0 so that we can get the value of y, and then same process. So let's rewrite first. 3x plus 4y less than or equal to 72, x as 0 plus 4y equal to less than or equal to 72, and we all know any number that is multiple to 0, that is automatic 0. So let's eliminate this one. So it will remain 4y less than or equal to 72. Let's divide both sides so that we can get for the value of y. So the y is 18. So let's say 18 is over here. So 18 for the value of y-intercept. How about x-intercept? Same process, substitution. So let's rewrite 3x plus 4y less than or equal to 72. 3x plus 4 multiplied by 0, 72. And we all know this already eliminated. So 3x less than or equal to 72. Divide both sides by 3. So for the value of x is how many 3 in 72? So that is, yes, 24. So for the value of x or x-intercept is 24. So let's say 24 is over here. Okay. So now, let's try to find the feasible region. Okay, before we move to the vertices. So after we graph, let's find the feasible region. So let's say, according here, if we're going to look, these are inequality symbol. So for us to determine whether solid line or dashed line are we going to use, remember that solid line is greater than or equal or less than or equal to. For the dashed line, that is less than or greater than. So meaning we're going to use solid line here. So let's say solid line for the first inequality. Okay, so solid line. Oops. Okay. Next, for the second inequality, so still that is solid line. Okay. So if we're going to notice, let's shade the first inequality. I'm going to use green. And then for the second inequality, I'm going to use orange. Okay. So if we're going to observe our graph, okay, our graph, oops, sorry. So if we're going to observe our graph, for the first inequality, I shade it as a green, and then for the second inequality, I shade it as a orange. So if we're going to look, the feasible region where two shaded are intersecting, so meaning this region. So let's shade that one. So let's shade. Do not mind my shading technique. Just that what I'm trying to imply is where those both shaded region met. That is your feasible region. Okay. Now, how about for the vertices according to step 3? Once you find the feasible region, go to vertices. If you still remember, vertices is where all line met, like intersect. So for the first inequality, this is the first inequality, and then second inequality is this one. So meaning they intersect over here. So let's use red. So they intersect over here. Now, what is the value of that vertices? If you're going to notice, there is no exact value here. So let's try to solve what is the vertices. So in this case, I'm going to use elimination. So all you have to do, copy this to inequality, x plus y less than or equal to 20, 3x plus 4, y less than or equal to 72. And then I'm going to multiply this first inequality to negative 3. So that will become negative 3x minus 3y less than or equal to 60 or negative 60 rather. If you still remember about elimination step 2, look for the same coefficient. So for the same coefficient is this one. So we have to eliminate that. So it will remain this 2. So let's try. Negative 3y plus 4y, so that is y, less than or equal. Negative 60 plus 72, so that is 12. So meaning our vertices is 12. So let's write our vertices here. So that is 12. Okay. So we done for the step 1, step 2, step 3. Now let's move now to the step 4. Substitute the coordinates for each vertex into objective function so that we can determine what? Determine the maximum value. So let's delete this one. So how we can do that? So for you to get the maximum value, all you have to do is create a table. Okay, for the table, it's like this. I'm going to use red. So this is x, y, and then z, right? Okay. What is for the first x or x-axis? So that is what? 20. And then for the y, still 20. Under what? Origin, 0. So let's try to use 20. And then for the y-axis, so that is 0. And then for the y, sorry, y is 18. And then 0 because under origin. Now, how about for the z? How about for the we already get the y-axis, right? That is what? 12, the vertices, if you still remember. So let's write here 12. How about for the x-axis or x intercept? All you have to do is substitute the value of y for the first. So let's say x plus what is y, that is 12, less than or equal to 20, and then transpose positive 12 to the other side, it will become negative. So for the value of x, that is what? 8. So right here, 8. Okay. Now, we already complete for the x and y axis. Now, how about for the z? For us to know what is z, all you have to do is use this first and the objective function so that we can get here. Same scenario, use this one and this so that we can get the value of z. And then last, use this one so that we can get the value of the third z. Let's try. Z equal 4. What is x? That is 20. Plus 5. What is y? That is 0. We all know this already eliminated. So z is equal to what? 80. Very good. So for the first value of z, that is 80. How about the second one? Again, use this so that we can get the second z over here. So z equal 4. What is x? 0. Plus 5. What is y? That is 18. So this already eliminated. And what is z? 5 multiplied by 18, that is 90. So this is 90. How about for the third value of z? Again, substitute for the value of x and y. Use this. Let's try. Z equal 4. What is x? 8 plus 5 multiplied by y. What is y? That is 12. Now, what do you think is the value of 4 multiplied by 8? That is, I believe, 32. Plus 5 multiplied by 12, that is 60. Combine, so the value of z is 92. So meaning 92. Now, going back to the example number 1, find the maximum value. Which do you think is the maximum value based on this table? Okay, awesome. The maximum value is this one. Let's use green. This one. That is your maximum value. So that's how you find the maximum value in the constraint, also in the objective. So how we can write the answer? So write the answer as this one. Z, sorry, let's write here. Z, okay. Z is, give me one sec. So for you to write for the value of maximum value, so that is Z, open parenthesis. So write the x and y intercept, so that is 8 and then 12 equal 92. So that's how you write for the maximum value. How about this example number 2? So on example number 2, we're going to find the maximum value of this objective function, which is g equal 4x minus y. And then these are the inequality or constraint. So y less than or equal to 4, x greater than or equal to 2, and then for the third inequality, we're going to transform first into slope intercept form so that we can graph it. Okay, so for the first inequality, so I do believe I already touched about that one. So y is equal to 4, y is less than or equal to 4. So simply, this is y, okay, and then put the line. So according here, that is solid line. Okay, next, how about this second? So that is 2 for the y-axis. So 2 is here. So simply put a line. Okay. Now, for the third one, like what I said, transform it into slope-intercept form. So if still remember, you have to move the first term to the other side. It will become negative. So that is 4y less than or equal to negative 3x plus 2. And divide both sides by negative 4 so that we can remain the y. This is cancelled. So the y is what? Less than or equal to positive 3 over 4 x negative 1 half. Why 1 half? Because this is divisible by 2, this last part. And this negative sign, so that that is become negative. So let's try to plot this slope intercept form. So negative 1 half, I do believe that is over here. So that is your first point. Second, using the slope, this is rise and then this is run. So rise and then run. So rise 3 times. So that is what? 1, 2, 3, and then run 4 times. 1, 2, 3. Okay? So that is our second point R or over here. Let's make it another one. So rise 3 times. So that is 1, 2, 3, then run 4 times. 1, 2, 3, 4. So your third point is like there. And then let's um, connect the dot. Okay, give me 1 sec. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Okay, there you go. Okay, let's connect now the line here. Oops. Okay, same solid line. So if you're going to notice, it create what? It creates a a triangle. And we all know once it create a triangle, inside the triangle are the feasible region. Okay? Now, after we determine the feasible region, let's put um, a shade green. Okay, there you go. Once we find the feasible region, now find the vertices. And the vertices are the line that is intersecting. So over here, here, and here. Now, what do you think is the first um, vertices? So let's say this is the first vertices. So that's it. That is what? X is 2 and then 4. Second, let's say this is the second. So that is what? X is 2 and then positive 1. And then for the third one, we cannot determine because that is what? In between of 6 and 7. However, for the y-intercept, that is 4. So let's write here x and then 4. Now let's find for the value of x. If you still remember my pattern or my step in finding it, this these are. Okay, so we're going to substitute for the value of y so that we can get the value of x. So we already have the value of y here, which is 4 in here. So 3x minus 4, what is y? So that is 4 less than or equal to 2. Multiply a number inside the parentheses, so that is what? Negative or positive 16? Okay, negative 16 less than or equal to 2. And then move negative 16 to the other side so that it will become positive. So 3x less than or equal to 2 plus 16. And then combine 2 and 16, so that is 18. Then 3x, divide both sides by 3. So what is, do you think, the value of x? How many 3 in 18? If we're going to use our calculator, again, it's okay to use calculator if you want. So that is 16 or 6 rather. So for the value of x, that is 6. Okay, so let's put here 6. Let's erase this one now. 6. So that those are our vertices. Now let's find the maximum value. The maximum value of this objective. All you have to do is write first all 3 vertices. So that is x, y, and then we're going to find for letter G. What is x? So that is 2. What is y? So that is 1. Second, what is x? That is 2. What is y? That is 4. And then for the third one, what is y? That is 4. What is x? That is 6. Now, substitute this term or for the x and y on this objective so that we can get the first g. So let's say x is 2 minus 1, that is y minus automatically, because this is positive, multiply the main operation instead of positive number, you will have negative number. So this is 14 minus 1, so that is 13. So for the first g, that is 13 under this first point. How about for the second g? So again, substitute 2 and then y, that is negative 4, and this is 14 minus 4, 10. So meaning for the third g, that is 10. How about for the third one? So 7 multiplied by 6 minus 4 equal 6 multiplied by 7, so that is 42, minus 4, that is 38. So meaning the last g is 38. So if we're going to observe, we're going to find for the maximum value of this side. So the maximum value is 38. Okay? So once we find the value of the maximum value, let's now write our final answer. So g, open and close parenthesis, so that is what? 6 and 4 equal 38. That is our answer. Okay? Okay.